I want to introduce to the stage our keynote speaker, Maria Zelenskaya. Technology, there we are. Hello,
Hello.
welcome.
Hi.
You're going to be talking to us about signing avatar animation pipeline using Auslan. Is that correct?
That's right.
Awesome.
Thanks for having me.
No, you're very welcome. I will leave you to it. Have a great talk.
Thank you. Thanks, Ben and everyone else. I'm very excited to be here today and to talk to you about our project. Yeah, I'll be talking about signing avatars and how we can create them and bring them to life using game engine technology. All right, so before I talk about the project, I'd like to explain where I'm coming from and what my skill set is. So I'm an animator and I specialize in motion capture technology. So my background is in design and screen production. I've never worked in game development, and I'm coming from a world of non-real-time graphics. But a few years ago, I started getting interested in game engines because I realized that the applications have gone beyond game dev and that they can offer some useful tools for someone like me. And I got particularly interested in virtual production tools and ways to use motion capture to animate characters in real time. All right. So last year, my interest in real-time animation brought me to the University of Queensland, where I joined a small research team working on this experimental project that was codenamed Alexa for Auslan or Alexa for the Deaf. And the goal of the project is to make the technology behind the eye assistants like Alexa, Siri, or Google Home accessible to deaf people, because they're all voice operated, which means that deaf people can't use them. And the studies show that the deaf community is actually interested in this technology and would like to benefit from it like everyone else. So it makes sense to create an AI assistant that communicates in Auslan. So here's how it's supposed to work. A user signs into the camera, the system analyzes the video feed, recognizes the signs, processes the request, performs the requested action, and reports back in Auslan. So, for example, a user might sign, Alexa, turn the lights off. And the system will turn the lights off, and an avatar on the screen will sign, okay, the lights are off now. You might ask, what's the point of having an avatar? Can't you just display text? And the answer is actually simple. Many Auslan users actually consider Auslan their first language, and English or any other language would be their second language. And they might actually prefer sign language to text messages. So it only makes sense to give them both options, so they can choose whether you want to have an avatar with subtitles on, or just the avatar, or just the text. So signing avatars are nothing new. They've been around for a while, and historically they haven't always been good. Many early avatars had poor graphics and robotic animation, and this earned them somewhat bad reputation in the deaf community, and they're often considered a bit of a gimmick. But the avatars are definitely getting better, the graphics getting better, the animation's getting better, and there are a few high-quality avatars that popped up in recent years, and that sparked some community interest, but still only a few. And most of them use either American Sign Language or British Sign Language or New Zealand Sign Language, like this last avatar here in the Christmas outfit. But of course, we're in Australia here, and we want Australian Sign Language. And we want the avatar to be good. So if we look at how signing avatars are animated, there are a few key approaches. The most popular one is animating the avatar using the traditional keyframe animation. And this means having an animator or a team of animators manually pose the character and make all the hand shapes. So possibly they might use some video reference while doing that. And this approach can produce great results, but it's incredibly time consuming, especially if you need to bring in an expert to check all of the signs and make sure they're correct. And it might be difficult to produce a large library of animations using this method. The second method is to use AI to generate signs automatically, for example, by translating text into a series of signs. Now, this approach is really still in its infancy, and the resulting animation looks very robotic and often doesn't include facial expressions that are an important part of sign language. And finally, there is a new approach that involves motion capture, and this allows recording the natural gestures and facial expressions of a native signer. So this result can look, the result of this method can look very natural and human-like, and a large number of animations can be recorded quickly. The problem with this method is that it requires a higher budget and more specialized expertise from the production team. But of course, in our case, this is exactly what my expertise is. And in the end, we ended up using a combination of all three methods. So throughout this project, it was very important for us to make sure we consult Auslan users and understand what they want from the device, how they would use it, what kind of avatar they'd like. And for this reason, we have a deaf advisory group that is involved in the design process. Early in the development, the team conducted a series of interviews with members of the Queensland Deaf Community to ask for their opinion. And we're also very lucky to have one of the leaders of the deaf community and an expert on Auslan learning on our team, Julie Lyons. Earlier this year, we had a co-design workshop where we invited several deaf participants of different ages to test our prototype and provide feedback, suggest ways to improve it, and just talk about it. We collected incredibly useful feedback, and the participants raised some great points during the workshop. For example, we discussed what color should the avatar's clothes be, what color should the background be to make it less distracting and easier to follow, whether they wanted to be able to customize their avatar's age, gender, race, or any other features. What would they name it? What personality should it have? And so on. It was an amazing experience for me as a creative and also as a hearing person, because it gave me a great insight into what Auslan users are like and what they want from our product. And the truth is, the deaf community has a very clear idea of what works and what doesn't work for them, and they feel strongly about some of it, which is why it's so important to have the end users as co-designers and to have them involved at all stages of the design process, or to at least provide quality control. So here's a list of all the design considerations that we can come up with. The avatar needed to be able to respond to different types of commands by playing different animations and transitioning smoothly between the different animated states. So for example, from idle state to signing, then back to idle. So it definitely had to be in real time, which ultimately made us lean towards the Unreal Engine. The avatar should look human-like and realistic. Now, many signing avatars are cartoonish, but some deaf people actually don't like that, and they think that's more suitable for kids. And they also want the signing to be smooth and natural, because otherwise it can be distracting. The only problem with the realistic, hyper-realistic avatars is that sometimes they can look kind of creepy and trigger the uncanny valley effect, but there are ways around it. The avatar must use appropriate facial expressions when signing, because mouthings are a big part of the sign language, and the expressions must be very clear and easy to read. The avatar must be customizable, because our users said they wanted to have a choice of different avatar designs to suit their personal preferences, and also because we want to continue making adjustments to the avatar's look as we continue getting feedback from the advisory group. Finally, because we decided to use motion capture, the avatar had to be mockup friendly. That usually means having some sort of standard rig, and it would be especially great to be able to stream animation directly into Unreal Engine using LiveLink plugin. So right around that time, Epic officially released their MetaHumans, And if you lived under a rock and don't know what metahumans are, they are these customizable digital human models that can be created and edited using this very user-friendly web application. And the characters, they come out already fully rigged and already optimized to use in Unreal Engine. So metahumans were perfect for us because we could create quickly multiple alternative avatars that use the same rig. They also have very good facial rigs and can make a wide range of facial expressions. And most importantly, they have built-in support for Unreal's Live Link Face app, which means it's easy to animate their faces using an iPhone camera. So in terms of motion capture, there are multiple solutions available on the market for different budgets. For example, the Vicon optical system is very good and can record high-quality motion data, but it's also very expensive and not necessarily good for hand tracking because finger markers are very small and they're hard to track. So you need quite a few cameras to set up close to the performer to get a decent result. And in any case, it's out of budget for most creators. Stretch Sense gloves are probably the best for capturing sign language because they're very sensitive and they can capture gestures that no other system can. But they're also quite pricey and might not work with all mockup systems, although they are adding more and more support. Perception Neuron is a very popular inertial system. The latest model is in the medium price range and integrates well with Unreal, but the tracking is not precise enough to capture sign language, so quite a bit of cleanup is required. Rococo is a very similar system, but cheaper. It also has good integration with Unreal and very similar limitations as well. So this is what we started with for our project. The quality was not great, but it made sense and it suited most of our requirements and it was very easy to use. But finally, we settled on the Accent setup with Manus Prime gloves. It's a similar inertial system, but a bit better than Rococo and Perception Neuron. And it's also in the medium price range. I'll let you find out the actual prices on your own. So here's how it works. We have a performer in the motion capture suit signing into the iPhone camera. The body motion data, including the hand gestures, is being processed by the Mockup Studio software, in this case, the Xsense NVM Animate. The facial expressions are tracked by the Live Link Face app on an iPhone. What happens next is a bit unusual for mockup productions because normally you want to record motion data, clean it, retarget it, fix it in something like Maya or Motion Builder, and only then import into Unreal Engine. Our team didn't have time for this, especially because I would then need to synchronize the body and the facial animation and put it all back together. And we also needed to produce a large number of animations quickly. So I decided to stream directly into Unreal live and record using Take Recorder. I then cleaned up and edited the recordings directly in Unreal Engine using MetaHuman control rig, face and body together, so already in perfect sync. This has become possible only recently. I think the control rig was added about a year, maybe more than a year ago, but it became stable enough to use only with the release of Unreal 5. So I can now edit the animation without Unreal crashing all the time. It's great. So this is the result. This is our MetaHuman avatar that we originally called Alyssa while testing, and it's performing one of the animations we've recorded. So just an example where she says the train is cancelled. And this is the original performance. So on the left is the source, Julie, our Auslan expert, signing in the accent suit. And on the right is the animation output. So you can see it's slightly different, but mostly the gestures and expressions, they're all there. Now, unfortunately, to get the result I've just shown you, I had to do quite a bit of cleanup. So on the left, is the original recording, and on the right, the edited version. So as you can see, the gestures and the facial expressions are mostly all there, but the position of the hands and the rotation of the shoulders and other joints, it all had to be fixed. And this is a limitation of most motion capture systems, but particularly inertial systems, because it just doesn't know where exactly in space all of those joints are. So it tracks the rotation of the joints, but not position. So it just all had to be fixed. And some signs were also too subtle, so they were completely missed. And so I had to basically add them in post. But still, it was much quicker than animating from scratch. And at this stage, our Auslan expert, Julie, she would come in and look at all of the animations and point out any problems and made me fix them. So over the course of the year, we've been slowly building a library of different animations. Interestingly, the face and body animations had to be saved separately because MetaHumans actually have two separate rigs for the head and for the body. So I just had to make sure that all changes, any changes to the body animation sequence, they're mirrored to the facial animation sequence, especially in terms of the length of the clip. Then I set up a simple animation state machine and to make the avatar transition from idle state to alert to different sign-in states. Now, I'm not a game developer, so I just did it the easiest way I could. And then I passed the project on to our data scientist, our developer, who works on the part of the system that is responsible for sign recognition. And so now we are working on connecting the two parts of the system together so that we can receive camera input and trigger the animation output. It basically works like a simple chatbot at this stage. So here is a demo of our system in action. This is just a proof of concept. It's all prepared and staged, but it shows you how the interactions are supposed to work. And the user signs into the camera and the avatar responds, and they have a bit of a conversation about weather. And like you see, the user asks something that the information is not available. So the avatar just says, well, I don't have that information, but it can receive other instructions. Oh, all right. So up until now, we've been working with pre-recorded signs. The next step is to start generating signs, generating new signs that aren't already in the library. We are not there yet to actually generate new signs, but what I did was prepare a fingerspelling library. They're basically Auslan letters that are put together to make a word. This may be appropriate to sign someone's name, for example, but there are also other things in Auslan that are spelled this way. So for fingerspelling, I had to set up a transitional pose with hands up, held up high for a smooth transition between letters and numbers. So what's next? First of all, we will continue growing our animation library, adding more signs to cover more topics. Then we'll start looking more into procedurally generated signs. This is tricky, and we'll have to find a way to seamlessly mix pre-recorded and generated signs without it looking too weird. Then possibly we might make a prototype of the actual device so that we can test it further and get it out there. And finally, we hope to forge new partnerships and maybe get more funding to continue our research. Our hopes and dreams for the future is that one day there will be a commercial home assistant device available that one can buy in a store and put in a kitchen somewhere. Or it could be a mobile app for iPhone. It would also be great to have a large national library of high-quality mock-up signs that others can access and use for their projects. And finally, I'd like to acknowledge the fact that I'm only an animator working in a team of brilliant researchers and professionals at the University of Queensland. Jess is our lead researcher, and this project is her baby. Scott is the lead developer and data scientist. He works on the sign language recognition system. Julie is our Auslan expert and our link to the deaf community. And Adele is our brilliant research assistant and also an Auslan expert. The research receives funding from the Queensland government and the Department of Defense, and my own work on this project is also part of my doctorate research through the University of the Griffith University. All right, this is the end of my talk. Thank you. I hope I inspired some of you to use game engine technology for something other than games and to embrace it outside the game development industry.
Thank you so much, Maria. It was amazing. One of the best things about being an MCs is I get to ask the first question before anyone else does. I'm a huge advocate, and I love accessibility in games. I've never thought about Auslan before because obviously the barrier to entry is far too big. Have you seen it used in games or in the space before?
Not really, but I think it's very important not to be intimidated by it, because even if you don't use Auslan, for example, and you don't know anyone who uses it, it's still you can still challenge yourself and try using the technology, creating the technology for it, and then find connections in the deaf community and find someone who can help you with the project. So don't just, just think that, oh, I have to stay away from it because I'm not part of this community.
Do you have any major advice for anyone looking into this space to actually, apart from ask someone who speaks Auslan, obviously, is there any other advice you would have?
No, I think that's my main advice. Just, get yourself out there, especially if you're, so I'd say being interested in the technology is enough to start with. You don't have to necessarily have a plan in mind on how to make it, make an accessible game. You can start with the technology side of things, especially for someone like myself who comes from the technology background, right? I approach this project as an animator and as a technical professional. So I think, yeah, it's all about forging those partnerships and bringing what you are good at into it.
Awesome. Well, we're about to move into a roundtable to discuss everything.